Alright, hi everybody. In the last video, I basically got it wrong. I said that we were dealing with some kind of memory problem, and that was why the pool didn't seem to be working. But it was working. There was no bug, it turned out. So we're not actually going to be looking at leaks today because there's just nothing to look at right now. We may get to it a little bit later, but for right now, there's just no memory leaks that we have to be concerned about. But there are still some things we want to do before we actually get to the main point of this video, which is going to be we're going to be doing some kind of results screen for the game. So if the player beats their previous record, they should know they beat their previous record without having to have it in their mind. So we're going to do that, but first we're going to be making a couple more changes to here. So I don't know why I haven't been doing this, but I haven't been making the text very big, which seems a little bit silly, frankly. The first thing I'm going to do is I'm going to fix that alloc because I know we were talking about in a previous video where we're trying to not use as many acronyms or shortenings, etc. So we're just going to do allocate objects, do that, and you can see now we have this allocate objects. It's a little bit clearer. That takes us to this pooled linked list. So pooled linked list, this behavior right here is just frankly, it's no good. There's no reason why it should always be 20. It frankly makes no sense. For testing, it's perfectly fine, but for this, it's just not good enough. So we're going to get rid of that line, but what we're going to do is we're going to add a second constructor, size t, right? And we have the size t pool size. And then maybe we'll do it like this actually. Object pool, we can do a constructor, right? Object pool type t, and then I don't think we actually need this, by the way. std : size t initial pool size. Delete this, don't need that. Right? And then we can do this, and then we can do alloc objects, and then it will be initial pool size like this, but obviously we don't want to force the user to use like that, so we can just do this too. So we have our default constructor, right? And then we also have the ability for the user to say, I actually want more objects at the start. So now we have this object pool, which is kind of cool. So in this, right, instead of doing like alloc more, what we can do is we can say pool size like that, and that'll work, I believe. Let's see. Nope. Oh, there's a in the object pool, I don't know why I just did that. Include log hpp. So now if we go, are we good? We're good. Okay, cool. So we have these default constructors which let us basically say we want the pool to be this big, this big, this big, etc. Or we just want to start out empty and we'll allocate as we go. So there's different kind of memory allocation strategies, even though it's the exact same strategy. So that's looking good. That's looking good. Now let's actually run it with, I think it's game header file. Yeah. So what we'll do here is we'll do commands. And since this is our code, right? This like pooled linked list, this object pool, that's meant to be used by other projects down the line. But this one like game thing right here, this could be used only for Sokoban as far as I'm concerned. So we can be a little bit more specialized and say like, we want 50 commands at the start. And if we run it, and then we go here, and this actually shows kind of an annoying thing I've noticed, which is I set up Sokoban and it works on Z really well as in all the previous videos, but I updated it today and you can see all of a sudden this isn't working. But if I go to here, and this is just iTerm, and then I run it, one, you can see the colors are a little different. That's fine, that's life. But you can see that this is actually working correctly where the X's aren't being shown unless we're highlighting. So something got messed up in the recent update for Z, or we have to rethink the way we're rendering. For now, I'm going to work under the assumption that something is wrong with Z. But we can go here, 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 here. And then the log file is actually probably messed up. So let me actually start that again. Right. And then we can go here and we can go into the log.txt file. You can see we were just getting stuff and everything's looking good. Which means we can get into the results screen and we can always change this. Is there like a constant? Yeah. So we'll make it like this. 50, right? And then we'll do, I think we've become, there's like that pirate software thing. And I saw the video of the guy who is basically harping on magic numbers. And I feel like we've become almost overzealous about seeing a magic number and just saying this is automatically bad. In this case, in the pirate software thing, I think it was like a huge array where different numbers meant different story events. So not great, but just as a general rule, maybe we shouldn't be so overzealous about saying all magic numbers are bad. But in this case, you know, whatever. So we got rid of the magic number, so that's looking good, which means we can start looking at what we're going to do when, for example, let me go to save.txt. Right over here, the player decided they want to solve the level in less moves, right? I didn't need to make that. They play, and we do this. We got it down to 6. A record was broken for their local save. Can we do something to celebrate that fact? I don't think we need to do a win screen because that's pretty clear based off of the thing turning colors, right? You get new things when you win. But I do think there should be some kind of notification, let's say. What is my application state implementation doing? Oh, it's the, yeah, okay. That is fair. Okay, so there are these. And basically what we want to add is some kind of information, let's say, for the user to basically figure out that they've done well. So what I'm going to do is I'm going to add a char star game over message. I'm going to go back into those constants. Char star move message, let's just say, and it will be you beat, what do I want it to be? Because basically what I'm thinking of is right here we can add a message if the user beat their record. So it would be like const char star time message, right? And it's like this. And then it's const char, well actually I think we just do both and we can always just move it down a little bit. Yeah, that seems fine to me. So we go here and what we do is you beat your move record from blank to, you beat your move record from what it was to what it is. And then we'll also do this, your time record from this to this. And it's saying there is an ODR violation kind of thing. So we'll do it like this. I'm actually kind of, I've never actually used const. Can I use that? Does that solve it? No. Okay, cool. So what we'll do is we'll take this. We're going to take this there. Now we go into constants. I don't love this, but we'll do it for now. What we can do instead, I think we'll solve it maybe. Yeah, so that's gonna fix our ODR thing. And then we get rid of this, and we'll just do it like that. I don't love it, but that's okay. So we do this, and then game over time, char star, game over, moves. Let me put this there. Let me do this, and we're always going to set it to null pointer by default, right? So that works now. Well, it doesn't work, but it is something. So now what we do is we go over here. So this is where we calculate the, where is it? Min, right? These two, where we actually set the min moves, min seconds played. So we're gonna actually change it so we have to do some branching, unfortunately, which is okay. So if ld.moves is less than app state, no. We want is greater than app state moves. Right, so this basically means, in this case, this is the level data, right? So this is the record that the player currently has. And if it's greater than the moves, then what we do is we say ld.moves is equal to, yeah, I got it, app state moves, but we actually, swap, right? So we're gonna actually swap these. And the reason why we're swapping it is because we still need for the message what it used to be. So when we show the message, we're gonna use app state. And then what we can do is we can say, what is it? App state move message, where is it? Game over move message. I just need the message there. Cool, is equal to, and then we do from the constants, right? Move message. And I guess this is gonna say this doesn't work. Yeah, that's fine. We'll come back to that in a second. And then otherwise, right, it is equal to a null pointer. We're gonna fix this in just a second. The other one is the exact same. Seconds played is greater than app state. That's seconds played. Nope. Where am I getting wrong? Oh, it's just seconds played because I already, yeah, there it is. So we'll have to figure out how we're going to deal with that in a second. So now we have our seconds played, right? We'll do app state game over time message is equal to time message. And then we need to do something with this, so we'll come back to it in a second. Right, and then in the other case, where there's no message for the user, it's game over time message is equal to null pointer. Okay. So we have our seconds played. Where do we get it from? We get it from over here, ms played, which we get from this over here. So we need one more variable, unfortunately. Seconds played is a double seconds played message. Cool, we'll do that. I don't love that variable name, but that's okay. And then instead of swap, right, we just do, you can see that's wrong. That's better. App state seconds played message is equal to seconds played. So now we have that. we can get rid of this for now. We're just going to comment it out. Looks good to me. Now we want to actually finish or figure out this problem right here where basically I tried to do this, but this is saying you can't do that. So we're just going to actually do it. .cpp hashtag include this. I'm sure there's a better way. Oh, I know. I'm stupid. Sorry. It is. This is what I always have trouble with. So we do this. C const. There it is. So, my bad. So what this is saying is if you think of it left to right to left, right? So const char. So it's saying all of these are constants. And then it's saying this pointer is const, whichever way you want to go. Probably right to left or left to right is easier. So this character is constant. This pointer is constant. So it's saying this whole thing cannot change. Always forget that. And actually it's right there. So I really shouldn't have forgotten that. Okay. Anywho, let's keep going. So now we have this time message in this, which is basically saying this game over message must be, can I get away with it like this? We'll see in just a second. We can totally get away with it. Okay. So now what we'll do is we'll just run it for a game, right? We do this, we do this. We can't actually get into the code that matters. So let me actually fix that real quick. Save.txt 60. We'll just do that preemptively because we're going to use that. Run. Right, and you can see everything's still working. Moves went down to 6, so that's good. So now what we want to do is we want to go into our level progression screen. And then what we want to do is we want to change our rendering. Okay, so where is it? Level progression. And then you see we have these right here. Now what we're going to do, y plus equals 1. What we're actually going to do is it like this. If app state move message does not equal null pointer, right? Then we do this. And then we'll do some rendering, but the thing we do at the very end is we're only going to show this once. Game over message equals null pointer. I don't love this kind of logic, right? Because there's logic that isn't rendering focused. Well, it's kind of rendering focused. I don't know, this one's a little iffy for me. I try not to have any game logic in the actual rendering, but this is UI logic, so it's a little bit weird. Render game or fewer moves by user if relevant, right? We'll do something like that. Yeah, for level makes that a lot better. For level by user if relevant. So we'll do this is equal to null pointer, and then what we do is we do move. Yeah, so now what I want to do is I want to do const char star message full message is equal to std format, right? And we're going to use app state game over message, and there are two things that we need. We need from before, right? Where to go? We need this, where we swapped it. So we need the level data, which is the selected index. So we'll just take this, right? And this is going to be, this is the new data. So this is going to be ld.moves, right? But it's also over here where we need the from to. And so this is going to be, if I'm not crazy, which is debatable, the app state moves. Cool. Okay. Now we need to C-stir it. And that looks fine. Object will be destroyed at the end of the full expression. Okay, we'll come back to that in a second. We'll do this, I guess. And this is gonna be of type just string, I guess. std. Oh, it needs a name. And then over here, char int is not a constant expression. So this can't actually take in a, so let's see if it can std with const char star. I know it's const char star star, or double, like so it's saying it can do it, but it's, yeah, we can never really trust AI, frankly. So I guess it's saying we could make like a copy of the string, which I don't love. Yeah, we could look at like this kind of thing. We'll just go here. So we have our buffer, which we would put it into. But how else could we do it that's a little bit cleaner? So let's go back into constants. Char const char star. So this is going to be percent I, and this is going to be percent, what is it? Where is it? 0.2f. Percent 0.2f. So this is our formatting message. We'll do it like that. And then we're going to drop this. And then what I want is like a format C string, C++, something like that. And then I'll also just put in, it is snprintf, right? Yeah, okay. So what we'll do is we'll have char buffer, and we'll make it like, we'll make it 50 characters just to be safe. We could be smarter about it because like we know how long this is, we know how long this is, and we could do that, but I want to use it for the next one too. Right, and then we put it into the buffer. And then this is, there's nothing actually returned in this one. I'm assuming that I'm missing an include. Okay, so I can't get rid of strings yet. Where'd I go? Oh, it's level progression. Okay, so I'm over here. I have my buffer. And then what's the problem now? The value is, that looks fine, value pi. If I make it, could I have just like, oh, it's not SN, oops, sorry. Okay, So it's saying it doesn't like snprintf, and then it's saying it wants us to use snprintf, which we were just using. So let's look at that to see what we need. stdio. What? Oh, this. Okay. Dot h. Do this. Then we'll go back down. It looks like there's some kind of error. And so it's saying what we need is a buffer, the size of the buffer. Sure. I guess that's the security thing. So there's no extra reading basically. And we do that. Okay. And if there's nothing, I don't think there's any message we really care about. So let's check the save file before we run. Okay, let's make it again for no reason. Then we'll do Sokoban, play, solve it super fast. Moves 12. But nothing showed up. And that may just because okay, one more press and nothing showed up. So the next thing to look at is the problem that I believe this is over here. I didn't move or print anything. So that would probably be why. Why, and then it's going to be the basic calculation that we've been doing a bunch, max x minus something, divide by 2, do this, strlen, and it's going to be the buffer, and then it's going to be print w, the buffer. All right, now we can try. Let me go back into our save file real quick to fix that. Now we can run it. Sokoban, play, do some extra moves just in case. Now we try moves 22, you beat your record from 60, your move record from 60 to 22. So I don't love the one line in between. So let's do a y plus equals 2 there, just for my own sanity. And then what we can do is we can say y plus equal, or plus plus y, right? We're going to do something very similar to this. So I'm just going to copy it over, because now we're doing for time, right? We do this, we get rid of this, and what are we going to do? Plus plus, because what I'm thinking of is, I guess we'll just do always plus equals 2. I'm okay with it. Because we could do like a special case, right? Where like if both were not a null pointer, we could do some other kind of message, but I'm okay with this. So we're in here now. We're going to use, instead of ld.moves, we're going to use ld.seconds. And this is going to be abstate.secondsplayed message. This is going to be time, right? Simple enough. Then this is going to be game over, nope, game over time message. Simple enough. Fix that if statement. And then I think that's it. So let's go into the save.txt file. Let's say this took 10 seconds. It definitely did not. Let's make this 20 seconds because we're going to test both after that. So we'll make it. And then we'll run it, play. So we have 22. So I'm just going to beat it super fit. I'm actually going to do this. So now I've done a bunch of moves. So you beat your time record from 8.42 to 10.12. So you can see that's not right. So we can fix that. Where there we go to game. And in here, we're going to just get rid of this because we don't need it anymore. But you can say I didn't actually do anything with the time. No, I did. I just got it wrong. What I didn't do we'll say LD dot seconds played is equal to seconds. There it is. So I want to do in this one LD seconds played, and then I want to do in this one seconds played, and then I set it equal to that, but there's a problem where this is a double, this is a double, and it's saying you can't do that. So that's fine. So we'll not swap it. We'll do LD.seconds played is equal to seconds played. And oh yeah, and then what we'll do is app state seconds played message is equal to LD.seconds played. Oof. Okay, so now I think this is fine. Do this. Let's make it Sokoban play. So we have 22 in this. So I'm going to do a bunch of moves. So we're over 22, right? Now I just do that. And you can see it's now working. You beat your time record from 10.12 to 5.60. Our next save is 130.20.3. So I'm just going to beat this. And you can see we lose it after one, which I think is totally fine. We do this, do this, do this, do this. And we get 2 extra messages where you beat your move record from 130 to 13, and you beat your time record from 20.03 to 2.95. If we move once, we're back to how things used to be. And that is, yeah, I think that's going to be it. So that's undo working. We made our object pool just a little bit cleaner in terms of the way it works in terms of construction, where you can say, I want an object pool of this initial size. In the pooled linked list, we updated our constructor to actually be able to take advantage of this. So they can also say, they being the user of our pooled linked list, can now say, I want the pool to be initialized to this size at the start of the run. And then from that, we then went into making a kind of result screen where if the user beats their previous record, they get a temporary message which says exactly that. So yeah, that's this video. In the next video, I'm not really recalling exactly what I have planned. We may go straight into compiler flags. And because right now in our makefile, right, we're not really using any flags, but really like we should be using some flags like that WAll, for example, right? And if we make with it, I'm assuming we're going to get some stuff. I guess we don't. But basically, the other one we haven't done is we haven't done any optimization flags, and we haven't done any pedantic flags. There's probably going to be a lot of flags once we start making use of them, which point out problems in the code. I don't know if that's going to be the next video one. I'm kind of blanking, but I'll see you guys in the next one. And yeah, I hope you're enjoying because we're almost at the end now. Bye.